Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me Statistics and Quantitative Techniques. In this video, we are going to learn transportation, which is Unit 9 of your course Statistics and Quantitative Techniques. So, transportation modeling is what we are going to learn in this particular video. This involves developing an initial solution. Then the initial solution can be developed by using either northwest corner method. Then there can be the intuitive lowest cost method, or you can use the Vogel's approximation method. Then we have a stepping stone method in order to modify the initial solution in order to obtain the optimal solution. Then we will be learning special issues in modeling such as demand not equal to supply. So such kind of problems are called as unbalanced transportation problems, and there can be situations of degeneracies as well as. Learning objectives of this particular unit. So when you complete this module, you should be able to develop an initial solution to a transportation problem with the northwest corner method or lowest cost method. Let me tell you at this juncture only that there is one more method which is known as Vogel's approximation method. So there are three ways by which we can find out the initial basic feasible solution to a transportation problem. Once we find out the initial basic feasible solution to the transportation problem, we have to find out the optimal solution by modified distribution, that is stepping stone method. The second step is solve the problem with the stepping stone method, balance a transportation problem. So there can be situations where the demand is not equal to supply. In such situations, we need to balance the demand and supply by using some dummy rows and dummy columns. Then we have to solve a problem with degeneracy. What is a transportation problem? An interactive procedure that finds the least costly means of moving products from a series of sources to a series of destinations. So business organization cannot have their manufacturing facilities at all the location, at all the geographical positions. So they have their manufacturing facilities at some fixed locations, and from those locations they have to cater to the needs of the people across the world. So there are various types of cost involved while transporting the manufactured goods from the factories, manufacturing facilities to the warehouses. So this transportation model consists of finding the cost effective manner of transporting the goods from factories and manufacturing facilities to the warehouses. So there are sources of origin which are also factories or manufacturing facilities, and there are destinations which are the warehouses, right? So can be used, transportation modeling can be used to help resolve distribution and location decision. So transportation problem can also help strategically locate the manufacturing facilities also and the warehouses also. So an organization can strategically locate the warehouses as well as manufacturing facilities in order to decrease the total transportation expenditure. Transportation modeling, a special class of linear programming. So it is a special case of linear programming problem. So transportation modeling is nothing but a special case of LPP. What do we need to know? The origin points and the capacity supply per period. So what we should know about, what data should we have in order to formulate a transportation problem. So we should know all the origin points, so where the goods are originated, that is the manufacturing facilities, and the capacity or supply per period at each. So we should also know the supply capacity of each of these manufacturing facilities. The second point is the destination points and the demand per period at each. So we should know various destination, that is the warehouses, and their demand. Right, the cost of shipping one unit from each origin to each destination. So there should be, we should know the cost of shipping one unit from each warehouse, each manufacturing facility to each warehouse. Transportation example. The following example was used to demonstrate the formulation of transportation problem. So both tubes are produced in plant in three different cities. Sorry, bath tube it is. Ahmedabad, Indore, Hyderabad, and the tube is shipped to the distributors in railroad. Each plant is able to supply the following number of units: Ahmedabad 100 units, Indore 300 units, and Hyderabad 300 units. So these are the capacities of three different production plants. Tubes will be shipped to the distributors in three cities: Mumbai, Kolkata, and Delhi. The distribution requires the following units: Mumbai requires 300 units, Kolkata 200, and Delhi 200. So this is the demand from each of these warehouses. So I repeat, bath tubes are produced in three different plants of a firm. The manufacturing facilities are located at Ahmedabad, Indore, and Hyderabad. The capacities of each of them are given: 100, 300, and 300 units respectively for Ahmedabad, Indore, and Hyderabad. Then these tubes are shipped to the distributors in three different cities: Mumbai, Kolkata, and Delhi. And the distribution requires the following units. So these are the capacities: 300, 200, and 200 for Mumbai, Kolkata, and Delhi respectively. Then shipping cost per unit. So the shipping cost per unit is mentioned in this particular box. For example, from Ahmedabad plant to Mumbai warehouse, ₹5 is the shipping cost per unit. I repeat, in other words, to ship one unit from Ahmedabad facility to Mumbai warehouse, the expenditure is ₹5 per unit. For shipping one unit of quantity of some tube from Indore to Mumbai is ₹8. So this is also the essential data which is required in order to build a transportation model. Yes, so here we have the graphics. So we have Mumbai, this is a warehouse. Delhi is also a warehouse, and Kolkata is also a warehouse. So the demand at Mumbai is 300 units. For Delhi it is 200 units, and the demand at Kolkata is again 200 units. Ahmedabad manufacturing plants produces 100 units. Indore manufacturing plant produces 300 units, and Hyderabad manufacturing plant produces 300 units per period. So these are the three manufacturing facilities from where we have to ship the material to three different warehouses. So transportation problem, the matrix is given here. So Mumbai, Kolkata, and Delhi, these are the warehouses, or what we can call them is destinations. Ahmedabad, Hyderabad, and Indore, these are three manufacturing facilities which can also be called as sources, right? These 5, 4, 3 in rupees are the unit cost of transportation from each warehouse to each destination, each source to each destination. Then warehouse requirement. So the demand from Mumbai is 300. It is mentioned at the bottom of this column, Mumbai column. Then at the bottom of the column of Kolkata, 200 is the unit requirement of Kolkata, demand, what we can call. Then the demand from Delhi is 200 unit per period. Now row wise we have Ahmedabad plant's capacity 100. The Indore plant can produce 300 units, and the Hyderabad plant can produce 300 units. So we have three sources: Ahmedabad, Indore, Hyderabad, each of with capacities 100, 300, and 300 respectively. We have three warehouses or destination: Mumbai, Kolkata, and Delhi, and their supplies are, their demands are 300, 200 and 200 respectively, and these values in the bracket, in this particular smaller box represent the cost of shipping of 1 unit from that particular source to particular destination. So this is a model of transportation. From this we have to solve a problem. So this is a formulated problem now. So whatever the information was mentioned in this particular para is now taken into this particular standard format of transportation matrix. Okay, so check the equality of total supply and demand. So what we do when we have this particular matrix, what we do with this? We have to check the equality of total supply and total demand. So let us check it. So 100 plus 300 plus 300 is 700. So column addition is 700. Then 300 plus 200 plus 200, it is again 700. So supply is equal to demand. So therefore the problem is said to be a balanced problem. If the problem is not a balanced problem, then we have to add a dummy row or a dummy column, and then we have to write the deficit demand or supply in in the dummy row or the dummy column. Okay, so how many ship of unit should be transported from each demand to each distribution center can be expressed as Xij. So Xij is the quantity of material that can be transported from each source to each distribution center. I for the demand, J for the distribution center. Then we need to establish the initial feasible solution. So what we did in the first step, we found out whether the problem is balanced or not. So if supply is equal to demand, the problem is said to be balanced problem. Otherwise, we have to add a dummy row or dummy column representing the deficit demand or deficit supply. So here we have three methods by which we can calculate the initial basic feasible solution, right? So the first method is northwest corner method. So start in the upper left hand cell or northwest corner of the table and allocate units to the shipping routes as follows. So this is the procedure to find out the initial basic feasible solution by northwest corner rule. So exhaust supply factory capacity of each row before moving down to the next row. Exhaust the warehouse requirement of each column before moving to the next column. Check to ensure that all supplies and demands are met. The steps of the northwest corner method are summarized here. Allocate as much as possible to the cells in which upper left hand corner subject to the supply and demand constraints. Allocate as much as possible to the left adjacent feasible cell. Repeat step 1 and 2 until all units of supply and demand have been satisfied. Okay, so assign 100 tubes from Ahmedabad to Mumbai. So in our problem, here we have the solution. So let me try to solve this problem in this matrix itself. Okay, so this is a northwest corner method, alright. So we are talking about a northwest corner method. So what we do, we choose a northwest corner. So of this internal matrix, this particular matrix I am talking about, this matrix, alright. So of this internal matrix, 3 by 3 matrix, we have this as the northwest corner. So this is the first northwest corner. Okay, so here the Ahmedabad plant's capacity is 100 units and the Mumbai destination's demand is 300. So what is the maximum quantity which we can allocate here? So 100 is the maximum quantity we can allocate here, right? So once we allocate 100 quantity here, the Ahmedabad plant's capacity is exhausted, it is over, and this value becomes 0. As we decide to supply 100 units from Ahmedabad to Mumbai, Mumbai's demand decreases from 300 to 200. So as the Ahmedabad plant's capacity has exhausted, we have already shipped whatever the 100 units Ahmedabad factory has produced, then we can eliminate Ahmedabad column from the matrix like this. Now as this particular row has been deleted, the next northwest corner is this one, alright, this one. So the capacity of Indore plant is 300 and the demand at Mumbai warehouse is 200. So what is the maximum quantity that we can allocate here, that we can ship from Indore to Mumbai? So 200 is the demand and 300 is the supply. So the maximum quantity we can supply is 200 because we cannot exceed the demand, right? 200. So as we allocate 200 units here, so this 200 will become 0, the demand at Mumbai will become 0 and the supply of Indore will remain as 300 minus 200, 100. Alright. So as the demand of Mumbai has been fulfilled, we can remove this particular column like this, right? Now the next northwest corner is this one. So what do we do? So what is the maximum quantity we can allocate here? So here it is the Kolkata, the destination, and Indore is the source. So the capacity remain at Indore is 100 and the demand of Kolkata is 200. So the maximum quantity which we can allocate is 100. Once we allocate 100, the demand will decrease to 100 and the supply of Indore get exhausted. Alright. So what we have to do, we can tick it off, we can tick Indore off from the matrix. Now we have only 2 boxes here, these 2 to be allocated. Alright. So the capacity of Hyderabad plant is 300 units and the demand at Kolkata is 100 and the demand as Delhi as 200. So we can directly write 100 and 200 here. Right. So this 100 will become 0, this 200 will become 0 and this 300 will also become 0. So supplies and demands have become 0 and that's why this is a feasible solution, we can say. So let us calculate the initial basic feasible solution. How do we calculate it? Summation of Xij multiplied by Cij. Cij is the cost of transportation from each source to each destination and Xij is the quantity to be transported from each source to each destination. So how do we calculate this? 100 is the quantity to be shipped from Ahmedabad to Mumbai, but the price required to ship 1 unit from Ahmedabad to Mumbai is 5. So this will be 100 multiplied by 5 plus 200 is the quantity to be shipped from Indore to Mumbai and the cost of transportation per unit from Indore to Mumbai is 8. So therefore 200 multiplied by 8. Similarly 100 multiplied by 4 plus 7 multiplied by 100 plus 5 multiplied by 200. So when we calculate this, we get some value 500 plus 1600 plus 400 plus 700 plus 1000. So this is equal to 2100, 2500, 3200 and 4200. So 42,000 actually, let me check it, 100 of 1000, 100 it is. So 4200 is the cost of transportation according to the initial basic feasible solution of northwest corner method. Alright, so the problem must have been solved here on the PPT also. So this is the procedure which we have already discussed. So this is the solution. 4200 is the initial basic feasible solution according to the northwest corner method. Then the second method is least cost method. So in this method, instead of northwest corner method, we use the cell with the least cost of transportation, least unit cost of transportation. Alright, so what is the procedure? Evaluate the transportation cost and select the square with the lowest cost. Depending upon the supply and demand condition, allocate the maximum quantity, maximum possible quantity. delete the satisfied allocated row or column, repeat the procedure 1 to 3 until all units have been allocated. So this is also a simple method. So in this method, we allocate the units where the cost of transportation is least. All right. So let us again refer to the original matrix. So here the least cost of transportation is 3, but there is a tie at 2 locations, here also and here also. So there is a tie at 2 locations, right? So what we can do in this situation, we choose the cell where we can allocate the maximum quantity. So in this particular cell, what quantity we can allocate? 100 is the capacity, 200 is the demand, so 100 we can allocate here. Here Indore's capacity is 300, Delhi's requirement is 200, so here we can allocate 200. So we choose the cell where we can allocate the maximum quantity, right, in order to resolve a tie. So similarly, we go on choosing the cells with the least cost, and then we go on allocating the maximum possible allocation there. So similarly, we find out the northwest we find out the solution, initial basic feasible solution, by the least cost method. So by least cost method also we get a different solution, initial basic solution, which is 4100. So by northwest corner we got 4200, by lowest cost method we get 4100. Now you will be astonished to know that the two different methods have given two different solutions, but these are initial solutions. I told you initially that the transportation problem is solved in two stages. First of all, we find out the initial basic feasible solution, and then we modify it by using the stepping stone method. So the testing the initial basic feasible solution for optimality. So what the solution which we have obtained by initial basic feasible solution by any of the methods, such as northwest corner method or the least cost method or the Vogel approximation method, we have to test it for optimality. The optimal solution is achieved when there is no other alternative solution give lower cost. So we have to check if there is any other solution which gives us lower cost. If there is a solution which can provide us lower cost, then we can say that this is not an optimal solution. Two methods for optimal solution are stepping stone method and modified distribution. Stepping stone method, so proceed row by row and select water square, a square without any allocation to evaluate. So we have to choose a square, a cell without any allocation to evaluate. Beginning at this square, trace forming a closed path back to the original square via squares that are certainly being used. So we have to form a closed path where the allocations have been made from this vacated square. Beginning with the plus sign at the unused corner, water square, and place alternate minus and plus signs at each corner of the path just traced. Calculate improvement index, the net cost of change for the path, by first adding the unit cost figures found in each square containing a plus sign and subtracting the unit cost in each square containing a minus sign. Repeat the procedure step 1 through 4 until you have calculated the improvement index for all the unused squares. So evaluate the optimal solution test by observing the signs of the net cost change. The negative sign indicates that the cost reduction can be made by making the change. So when we get the negative sign for the opportunity cost, what we can say that the solution can be modified, and if we get the positive sign, we can say that the reallocation is not possible, the opportunity cost is positive. All right, so zero result indicates that there will be no change in the cost. If all signs are positive, it means that the solution optimal solution has been obtained, and if more than squares have negative signs, then the water square and the largest negative net cost change is selected for quicker solution. In case of tie, choose one of them randomly. So if an improvement is possible, choose the route unused square with the largest negative improvement index. On the second path of that route, select the smallest number found in the squares containing minus sign. Adding this number to all squares on the closed path will plus sign and subtract it from all squares with minus sign. Repeat this procedure until you have evaluate all unused squares. Prepare the new transportation table and check for optimality. So this was the solution which we have obtained. Alright, so here we form the square. And how do we form the square? Look at this, this is the water square. Now we have given alternative sign, plus, minus and plus, right? So these were the allocation, 100, 200 and 100 were the allocation at these, these 4 cells, these 3 cells. This is the, vacated cell, unused cell. So what we are going to do, we are going to make some we have to check for the optimality. So how do we check the optimality? Here it is. So Ahmedabad Kolkata index is 4 minus 5 plus 8 minus 4, that is plus 3, right? So this is how we carry out reallocation, right? Then we form a closed path like this, right? And then we give alternative signs, and then we carry out reallocations. So after reallocations, what we get, we again check for the opportunity cost, and if all the opportunity costs are positive, we say that the final solution has been obtained. And the modified solution as per the stepping stone method is 4000, which is less than the initial basic feasible solution which we have obtained by northwest corner method as well as the least cost method. So this is the final solution, right, by stepping stone method. So this is how we find out the best possible solution to a transportation problem by using some matrix calculation, by using the northwest corner method and the Vogel's approximation method or the least cost method to find out the initial basic feasible solution. The same solution is modified by using the stepping stone method, right, and by using the stepping stone method we get the optimal solution which would be less than or equal to the initial basic feasible solution which we might have obtained by using the initial basic feasible solution methods. So this is all about transportation problem. Thank you for watching this video.